Okay, guys, a very warm welcome to my lesson for today, where we are going to be looking at your physical sciences. So I've got something here, honorable members, that I would like for us to quickly go through. Let me just check if my screen is sharing, so that if not, no, it's not. I'm therefore going to be sharing my screen. So this is more like a classwork, honorable members, where you will be attending to this question. So let's see, guys, are you able to see my screen? Can you clearly hear me when I speak? Guys, are you able to see my screen? Can you clearly hear me when I speak?
Yes, sir.
Okay, then it's fine. It's fine. So maybe let me write down there so that it is clear, just in case if someone joins while we've started. I'll just say classwork. Classwork. Today is 12/03/2025. Yes, this is a classwork on the members that we're going to be doing in today's lesson. So how we are going to be doing this is that I will give you enough time on each question. As soon as you are done, you then take a photo, you send to me via WhatsApp inbox. Then I'm going to check it, and then immediately we do the corrections, and then we move on to the next question. So for the first question, maybe let me give you guys enough time for each or time on each question. So for this one, you will need to submit at 19 quarter past. So for this one, you will need to submit any time before that time. So it looks like you've got let's say 10 minutes to work it out, even though by right you should not take that much. But I'm just giving you guys an opportunity to read through the given statement, interpret all of that, analyze everything, and then if necessary, check on your notes. It could be something that you did in class or something that we did together in our lesson. Then you answer the question after you are 100% sure. As soon as you are done with the answer, you send to me via WhatsApp inbox. And then very quickly, we do the corrections on that. And then from there, we move on to the next question. So this is going to give me an opportunity to be able to instantly check what you've done, notice what you're struggling with, and we address it immediately. Unlike a test where I have to go through everything for each of you, and then we do the corrections, then I address common challenges. But in this case, it means we attend to each and every question as we do it. Did you guys understand my explanation there? Tobani Lavella, Liseko, Nzika, or Phile, Serine, and Titelo. Did you guys understand what I was saying there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, 100%. Then it's fine. It's fine. I'll just do that. And you guys can go ahead and attend to that question. There's the time at which all of you must submit. As soon as you're done, take a photo, send it via WhatsApp inbox, and then I will check. Let's see. Let's see. Guys, how far are you? Lavella second lady, Nsika or Phyllis Ryan, Titelo and Toban. What's happening there? Are you guys winning?
Yes, I'm by 4.1.4.
No. You don't jump onto other questions, 4.1.4. So don't jump onto other questions. As soon as you are done with that first one you send, then I want to check on that so that once that is done, then we move on to the next one. I just want us to do it that way, step by step. This is so that imagine if all of you do from the first until the last. I won't get a chance to go through all your answers. So I just want bit by bit. You got it, honorable member. Question by
Yes,
question. Yes. Lavena second lady, Zika or Philip Serene, Titelo and Toban. What's happening there? Are you guys winning?
Yes, sir.
Yes, it's time to submit. It's fine whether you are done or not. It's time to submit. Please submit. Okay, we've got labeled on the 1K. There's the 1 kg. We've got that. That. Okay. Okay. And let me check on this one. Let's see. So got that, and that. Okay. That's interesting. Okay. And let's check on that one. We've got that. Okay. And then let's see, we've got that. Okay. Okay. I did see what you guys have done. So now, this is what I'm going to do. I will therefore answer that question without me having to criticize what you have done. I will just straight away answer that question just so that you have an idea of what goes into my mind as I answer that question. Then you will sort of have an idea of what you need to think of as you answer this question. Okay, this is what happens, honorable members. In the diagram below, a 2 kg block is connected to a 1 kg block by means of a light extensible string. The blocks are pulled up an inclined plane, which forms an angle of 28 degrees to the horizontal sides of the blocks, which ties the inclined plane have the same area. Okay. Then we've got the kinetic frictional force between the 1 kg and the block. Okay, and the inclined plane is 4 Newton, while the kinetic frictional force between the 2 kg block and the incline is 8. Okay, draw a labeled free body diagram showing all the forces acting on the 1 kg. We are now on the 1 kg. So I'm just going to make a dot for the 1 kg. I'm always going to start in this order. You firstly look 4, you don't even look for it. You must just know it's always there, force of gravity. The next force that you need to think of is the normal force. This one will depend if there is a surface, if the object is in contact with the surface. The next force that you should think of is the applied force. And then after the applied force, then you can think about the frictional force. And then lastly, you can then talk about the tension. This will always be there. This will be there if the surface is there. This will be there if they have indicated on the diagram, just like they did there. This one, it's either in the statement they will talk about the surface being rough or smooth. That one will depend on two objects being connected by a string. Also, the marks allocated will guide you in terms of how many forces you are to be having on the question that you are dealing with. No. Okay, so now you will notice that FG, okay, FG will always be vertically downwards. So that means we are therefore going to have our FG, which is vertically downwards. What other force did I talk about? The next one I said normal force. So normal force, it will be always perpendicular to the surface. So it will therefore be acting in that direction, and that will be your normal force. Next force, what did I talk about? Applied force. Okay, applied force, we can already see it is in that direction. You must also label those forces. Okay, the next force I said frictional force. In the statement, is there somewhere where they were talking about frictional or kinetic frictional force? Yes. The frictional force will always oppose the direction in which the object is moving. So the object will move in that direction because of the applied forces in that direction. So that means the frictional force will be in the opposite direction. So there you can just say that. Okay, what about tension? Those two objects, are they connected by a string? Yes. If yes, then it means the tension is there in that direction. So that is how for this question you score yourself 1, 2, 3, 4, 5 marks. So in the comment section, you can just let me know if you understood or not. Maybe let's say not in the comment section, but anyone who's got a question. If not, then I will give you time to answer the next question. Is there anyone who's got a question on that one? Did you guys notice your mistakes? Does it make sense how you're supposed to work it out?
Yes, sir.
Yes, sir.
Okay, then it makes sense. So the next thing that we are going to do, it is to move on to the next question. The next question, you are required to state Newton's second law of motion. Okay, I'm giving you 3 minutes on this question. So that means for this one, you need to let me know of the answer at that time. 25. So this one, you don't send a photo, but you write it in the comment section to 19.1925. So that means it's 2 minutes that you have. So you type it in the comment section and then you send it. Now is the time to submit. Let's see. What are you guys saying there? Let's see if you guys are lying. Mistakes noticed, say understood. Okay, good. When a resultant on net force acts on an object, the object will accelerate in the direction of the force and will accelerate directly from the force. That states that when a net force acts on an object, acceleration is the direction of the force and the force accelerates from and the acceleration is that. Okay. So now we are therefore going to move on to that next question, and on this one I am going to give you I'm going to give you until this time. I'm going to give you until that time, and again, what I'm going to do, I'm going to let you know what the final answer should be. So that means as you work it out, you should just work towards getting the answer that I'm going to give to you. In the meantime, you can just start working on it. Okay, the answer to this question, you must find that to be 20 Newton. Newton, yes. So that's what you must get, honorable members. As you work it out, you need to work towards getting that. If you do not get that, then it means it's wrong. You need to quickly redo it until you get that answer. Someone has got 20. Oh, okay. Yeah. This one was copied. This one. Honorable member, were you not copying? This question is very difficult. Were you not copying? No. No. Okay, another submission. Another submission. Let's see. Okay, guys, I did check your submissions, even though I'm not yet done checking for everyone, but this is impressive. What I'm seeing so far is impressive. So I think, okay, let me say, in the meantime, you guys can jump onto those two last questions while I check for everyone. And so far, what I'm seeing, it's okay. I just want to check if you guys did not just write the formula, submit, and then in the end, just say tension is equals to 20. I just want to check that thoroughly. I know you, sometimes someone knows that, okay, the final answer should be 20, and they just write the formula, they substitute, they just continue, and then from there, they just say this is equals to 20, and they leave it there. Okay. Okay, let's see this one. Also getting 20. That. Okay. This one also getting 20. F not, MA, that. Hey, guys, are you sure you're not copying? I wonder if you guys are improving or if you guys are copying. Never checking the submissions in the okay. Okay. This one is saying no. Okay. Okay. Then it's fine. It's fine. It's fine. It's fine. Will I have enough space there? It's fine. So there is some who requested for that to be done. But otherwise, based on what I've seen up to this point, I've got no objections, honorable members. I think it's safe to say I am impressed. Okay, so this is what happens, honorable members. Every time when you've got two objects which are connected by a string, just know that you've got two objects that can be separated. This one is for the 2 kg. Just know that for this one of the 2 kg, you've got the tension in that direction. You also have what is it? The kinetic frictional force in that direction. And again, I think it's safe to say you've got the V parallel, the component of that G, also in that direction, being a, what is it? Force of gravity parallel. This one, it is for the 2 kg. For this one of the 1 kg, we have already the built free body diagram. We said here we've got an applied force, number 1. And then we also have, it has to be a straight line. We also have that kinetic frictional force. And then again, we also have the tension in that direction. Obviously, the normal force will be there, but something very much important. It looks like we still have an additional force there in that direction still, which is force of gravity parallel. Not an easy question, honorable members. So what happens generally in this type of questions? You need to have 2 equations where you formulate and make T the subject of the formula for the 2 kg. You do the same for the 1 kg. The formula obviously says F net equals MA. F net means all the forces acting on that object. So we can assume towards the right as positive, meaning this will be a positive force, this one will be the opposing force, FG parallel. Again, this one will be the opposing force, and you can say this is equals to MA. Now let's try the substitute. We know our tension is what we are looking for. What is the formula for FG parallel? We said it is mg sine of an angle minus our FK. Do we have the value for that? Do we have the frictional, the kinetic frictional force on the 2 kg? It looks like we do, because there is a statement which says the kinetic frictional force between the 1 kg and the incline is 4, while the kinetic frictional and the incline is 8. Okay, so it looks like we already have that being 8, which is equals to, okay, we do have the mass. We do have the mass for the 2 kg, which is what? Which is 2. What we don't have is the acceleration. But what we know is that the acceleration for this will be exactly the same as that, because these 2 things are connected. It's like you can't have this one moving faster than that one while these things are connected. So that's why when things are connected together, you must just remember that they are accelerating the same acceleration. So remember, the main aim is to try and make that T the subject of the formula. Maybe let's continue to substitute. We have T. What is M? M is 2. G doesn't change. It remains as a 9.8. And then sine of an angle. Angle is 28 degrees. Minusing 8, which will be equals to 2A. We end up having our T, which can be equated to 2A. Then we take all of this, we punch it on a calculator, and then whatever that we get, we take it to the other side with opposite sign. So you may find that when you punch all of that on a calculator, it probably gives you, let's see, maybe let me quickly do it on my side. and say negative 2 times 9.8 sine of 28 degrees minus 8 gives me 17 point that. I take it to the other side, it becomes a plus 17.20. Yes. That's what I'm getting, unless if I made a mistake somewhere, or unless if I missed something very much important. Oh yes, it looks like I did miss something very, very much important. What did I miss? I missed another force, because I had the forces in the left. Wait, did I miss something? No, on this one I didn't miss anything, because the applied force is on that one. Yes, the applied force is on that one. What else is happening there? Yes, no, I think this is fine. I think I've done everything correctly, honorable members. So maybe we can regard this as our first equation where we made T the subject of the formula. And then now we can do the same for that other one. So for that other one, we are still going to say F net is equals to MA. F net, we have applied force. I always start with the forces towards the right. Then everything, it is just minusing, meaning minusing tension, minusing that FG parallel, again minusing that. Then you equate that to MA. That's how you expand the formula. Force applied, that we're not given that, we are given, which is 30 Newton, where we minus the tension is what we are trying to figure out. The mass, we are on the 1.4, the 1 kg, 9.8, sine of an angle being 28 degrees minusing. What did they say that is? I think they said it's 4. For the 1 kg, they said it's 4. So we've got our mass being 1 because we are on the one of 1 kg. So we have our 30 there. Maybe before one even does it that way, you can just say you've got that you need to work it out with that. Let's then punch that on our calc. So you'll say 30 minus into 1 into 9.8, and then you are having sine of 28, and then you minus 4. This is equals to 21 point that. So you have a 21,34 when you round it to the nearest, minusing T, which is equals to that times that is the same as A. So you end up having your T, if you take it to the right hand side, it becomes positive, which is equals to take A to the other side, and then you have your 21,34 minusing A. And that becomes your equation number 2. Then all that you do is just to solve a simultaneous the value of that and that, because This is more like solving for X and Y, honorable members. I'm definitely not going to continue with that one, but I will say, think of it as you are given Y, which is equals to 2x plus 17,20. This being your equation number 1. Equation number 2, they are saying Y again is equals to 21.34 minus X. This is your equation. Whatever value that you get represents guys, I did notice that I was disconnected. Considering that it's almost time for next lesson, let me just check. Did you guys understand what I've explained up to this point? Especially
Yes, sir.
that part where I was talking about simultaneous equation. You see, the reason why they taught you, or the reason why they teach you how to solve things simultaneously, it's because they knew at some point in physical sciences you will need to solve two unknowns in this type of instances, and then you need to solve things similar. So don't stress that much and say, okay, it's tension, now am I going to find? Just assume your T to be Y, your A to be X. Then you will easily work it out as if you are dealing with a maths equation. So guys, let me just end it here in preparation for the next lesson. But I'm very much impressed with what you guys have done, because especially that this question, it's a November exam paper, but you guys were able to answer that question before we are even on term 2. Okay, this is what I was explaining. I just noticed the screen was not sharing. Can you guys take a screenshot of that for your information? Okay, it might not even be necessary because this is a recording. So that means since it is a recording, you can be able to catch up. Okay, so guys, let me just end and jump onto